Okay, so again, we're going to do our angle launch problems. And this is number 6 in your packet, the first of the angled launch problems. If you have not tried these problems on your own, again, you want to do so before you go through the video. Let's get started. A soccer ball is kicked from the ground with an initial velocity of 25 meters per second at 28 degrees with respect to the horizontal. And it says, what is the maximum height reached by the soccer ball? And this may not seem like a lot of information, but before we sort of start panicking about that, let's diagram our situation and kind of work through it. So we have the ground, and we have a soccer ball, and it's kicked with an initial velocity of 25 meters per second at 28 degrees with the horizontal. So that's what it looks like. It's going to follow a nice trajectory here, and it wants us to look at the maximum height. So it wants us to look right here at this displacement, and so at this point we have to think, what does our velocity vector look like at this? So our VF is going to look like that, and it's actually going to be the x component of our initial velocity vector. So let's look at our initial velocity vector like this. (25 meters per second) at 28 degrees. So our initial y component is 25 sine of 28, and our initial x component is 25 cosine of 28. And so let's start filling out our table. So we have 25 cosine of 28, and we know that we have no acceleration in the y direction, so the initial and final in the x direction are equal. So I can fill those out. I want to find this y displacement, so I can put my question mark there to remind me what I'm supposed to be finding. And my initial y velocity is 25. It is positive. It's going up. You see it nice and clear here. 25 sine of 28. And I know up here that y component of the final velocity is 0, so I'll fill that in, 0 meters per second. And my acceleration is negative 9.8 meters per second squared in my y direction. So take a look at this. I want to find this y displacement. I have 3 out of my 4 variables, so I absolutely do not need time, nor do I care about the horizontal displacement. So I'm going to use the no t formula in the y direction to solve for my y displacement. And that formula looks like v final y squared is equal to the initial y squared plus 2a with the y times the y displacement. And so I know this final component is 0. And I am solving for y, so let's do a little algebra. Put this on the other side, minus v naught y squared divided by 2a, and that's a subscript. It's hard in here sometimes to denote the subscripts from the things that are on the letter. I try to make them smaller and try to make them near the bottom of the letter. You have to just kind of be careful of it. So my y displacement is equal to minus v naught y, so that's 25 sine of 28 squared divided by 2 times minus 9.8. Again, a reminder, making sure that you've got these signs in. And we could do all of this in separate, but there's no reason for that. We just stick it right all in the calculator and make sure that it makes physical sense. 25 times the sine of 28. Make sure you close your parentheses or hit equals before you hit that x to the 2 button to square it. And then you divide and make sure you open parentheses. 2 times 9.8, and that should have been a negative 9.8, and close your parentheses. And so you get a y displacement of plus 7.028 or 7.03 meters. Okay, so my answer, it says what is the maximum height? This was a displacement that I found. They're only asking for height. So my answer is 7.03 meters, and it's not a bad idea to put above the ground. But my height is 7.03 meters.